Hi guys, welcome to my channel, and today in this video we are going to discuss three-stage traffic light controller. So guys, for the full video, all of you stay tuned.
Karanjetlilive.
So guys, what is a traffic light controller? So traffic light controller is basically, it is a digital circuit, or it is a circuit which can control the traffic lights. Means it can control which light will turn red, which will be green. Okay, so now what do I mean by three-stage traffic light controller? Suppose we have these three streets. We have these three streets. Okay, one street goes to Muscat. Okay, so if you are watching my video for the first time, so I live here in Oman, and Muscat is the capital of Oman. So this is one city in Oman, and it is the capital. So one road goes to Muscat, one goes to Sohar, this is another city in Oman, and one goes to, for example, Rustak. Okay, so what the traffic light controller will do, it will control the access to these roads by turning the light green and red. Okay, now when Muscat will be green, okay, so here, okay, we have the green color. So when Muscat will be green, so then it will make other two lights, that is Rustak red and Sohar also red. Okay, and this it will work like a cycle. Suppose these are our different streets, okay, for which we have to design a traffic light controller. Okay, so first step is called as making a state diagram. First step is called as making a state diagram. Now you know we have three cities. One is called as Muscat. Okay, let us donate Muscat with state S0. Okay, then we have another city when the time is complete, so S1, and that city was Rustak. Okay, so then again when the time is complete, it changes the state to S2 and the city was Sohar, and again when the time is complete, again the Muscat comes. So total how many states are there? Three states, S0 for Muscat, S1 for Rustak, and S2 for Sohar. Okay, so what is this thing called as? It is called as state diagrams. And how the state changes? When the time is complete. When the time is complete. Now the time is decided by the clock pulses of the computer. Okay, so when the clock comes, means time is over, the state changes. So what is this called as? It is stage 1. It is stage 1. So what do we call it? We call it as a state diagram. We call it as state diagram. Okay, so now guys, from state diagram we write something called as a state table. So state table will have two things. One is the present state, and then is the next state. Okay, one is the present state, then is the next state. So guys, if the present state is S0, then what is the next state? Next state is S1. So if the present state is S1, then what is the next state? Next state is S2. The next state is S2. If the present state is S2, then what is the next state? S0. Then what is the next state? S0. So this was stage 1, state diagram. This was stage 2. So what do we call it? We call it as state table. Okay. So from state diagram, you make something called as state table. Okay, now the state table, now next stage, the state table we will convert into truth table. We will convert the state table into truth table. Okay, then from that truth table we are going to draw the circuit. Okay, now this is my state table. How I convert it to truth table, you will see. Okay, so guys, now let us observe this table. Let us observe this table. It is similar to your state table. So when the present state is S0, the next state is S1. When the present state is S1, the next is S2. When the present is S2, again we go back to S0. So guys, let us represent the present state with variable x and y. So total how many states are there? States are 3. To represent 3 states, how many variables we need? We need 2 variables. So x and y. And let us represent the next state. Let us represent the next state with variables p and q. So what is present state? S0. We also call it as a state 0. So what is 0? 0, 0. So what is, we also call it as state 0, state 1 and state 2 for your easy understanding. What is 1? 1 is 0, 1. So what is 2? 2 is 1, 0. 2 is 1, 0. So what is the next state? What is the next state? 1. S1 is 1. So what it is? 0, 1. S2 1, 0. S0 0, 0. Okay. Now what we want is, we want a circuit which should generate my next state. Okay, what will be the next light, which is green, and it should also generate the present state. What is the present light, which should be green? Okay, now present light muscat should be green here when this is the input. Then Rustak should be green here, and Sohar should be green here. So after muscat, what should be green? This one. So 0, 1 is what? Rustak. And so after Rustak, what should be green? Sohar should be green. And after Sohar, again the cycle repeats. Okay. So guys, I hope you understand up to here. So if presently muscat is green, then after muscat Rustak will be green. If Rustak is green, after Rustak Sohar should be green. If Sohar is green, then after Sohar again S0 muscat should be green. Okay. Now guys, here what we have. We have present states denoted by x and y, and we have next state denoted by p and q. So let us write the Boolean equation for the next state. So this is p. Okay, take all the inputs for 1. When the output is 1, what are the inputs? So what is the Boolean equation for p? P is x complement and y. P is x complement and y. So what is q? Q will be x complement and y complement. So these are my next states. So as I told you, this circuit will give us 2 outputs. One is the next state, that is denoted by p and q, and other one is present state. Presently, which light is green? So when the state S0, okay, what is green? Muscat. Okay, muscat is S0. So what is the Boolean equation for muscat? X complement and y complement. Okay, so then Rustak. So Rustak is S1. So what is S1? X complement and y. Then comes Sohar. So Sohar. So what is the Boolean equation for Sohar? It is x y complement. So we need a circuit which generates p and q, plus it also generates the present state which is green light. So Muscat will be green when the state is S0. Rustak will be green when the state is S1. Sohar will be green when the state is S2. Okay. So this is my next state and these are my present states. Okay. Now guys, we will make a circuit for it. We will make a circuit for it. Now as I told you, we have a present state and we have a next state. Okay. So the present state will generate the next state. So the next state should be stored somewhere. So the next state should be stored somewhere. Okay. Where do we store? In sequential circuit, we have a memory element called as flip-flop. Okay. We call it as flip-flop. So who will store our next states? Who will store our next state? So my next state is made up of two variables P and Q. One bit for P and one bit for Q. One bit for P and one bit for Q. So how many flip-flops I need? I need two. One for P and other one for Q. Now flip-flops will store my next state. So when the time is complete, the next state will become present and it will generate the new next state, isn't it? For example, today is Friday. Today is Friday. Tomorrow is Saturday. Okay. When I am tomorrow will become today, that is Saturday, and I have a new tomorrow, that is Sunday. So next becomes present. Okay. Next becomes present and then we get new next. The new next becomes present. So we need to store the next state P and Q. Where we will store them? We will store them in flip-flops. Then P and Q will generate the next. P and Q will generate the present states and they will generate the next states which with time will become present. Okay. So to store P is 1 bit, I need one flip-flop. To store Q is another 1 bit, I need one more flip-flop. So to store P and Q, I need two flip-flop. And P and Q, they generate X and Y. They generate X and Y. Okay. Now guys, in this traffic light controller, the flip-flops which we will use D-type flip-flops. We will use the D-type flip-flops. What is a D-type flip-flop? We also call it as data flip-flop. In data flip-flop, whatever is the input, same is the output. Okay. So as I told you, we will have one for P. So what is the input? P. And we will have one for Q. What is the input? Q. Now, here the output will be same. Whatever is the input, same is the output. As I told you, the next will generate will become present. So P goes, after the time is complete, P becomes X. X is what? X is present. Next will become present after some time. So here it has two outputs, one for X and always in the flip-flop. If one is 1X, another one will be X complement. So here Q will generate Y. Here will be Y and here will be Y complement. Then we will clock them. So what is a clock? Clock is the timing signal. Clock is the timing signal which will change the states. Now what is the Boolean equation for P? P is X complement and Y. P is X complement and Y. So this is X complement. I take it. P was X complement and Y. So this is Y. P is X complement and Y. So this is my Y. So what is Q? Q is X complement and Y complement. So this is my X complement and this is my Y complement and I AND them here. And what they become? They become Q. So what is Q? X complement and Y complement. So guys, this diagram I am drawing for your reference. In next part of this video, we are going to implement this circuit in logism. Okay. So where you can see it working. Okay. Now I need the states for present output. When muscat is on, muscat will be green with x complement and y complement. Already I have q, which is x complement and y complement, isn't it? So I take this connection and put a light here for muscat, and I put a light here for muscat. So what is Rustak? Rustak is x complement and y. So x complement and y is already p. So I take a p, take a connection from p and put here. What is this? Rustak. Okay. So what is Sohar? Sohar is xy complement. So here I have y complement. I take this y complement, and here is x, which was not used till now, and I AND them. So x and y complement will give me Sohar. Okay. So whenever clock comes, the lights will change. So they will generate two things: the next states, okay, and the present states for which the lights are green. So guys, I hope you understand up to here. So in the next part of video, we will implement these Boolean equations in a logism. We will implement it in logism, and you can see the circuit working. Okay, so guys, now this is my logism, okay, and we are going to make the circuit, okay, for the 3-state traffic light controller we just discussed in the first part of this video. So we need the circuit which will generate the next state, that is P and Q, and it will also generate the present state, that is the light should be green for muscat, Rustak and Sohar. So the Boolean equations which we discussed in the first part of the video, I have already put them here. So what is P? P is x complement y. What is Q? That is x complement and y complement. Okay, and muscat is x complement and y complement, Rustak is x complement and y, and Sohar is xy complement. So guys, I told you like we need to store the variables p and q. So to store the variables p and q, I need, because two variables, 1 bit for each, so I need two D type flip flops. Okay, here I go to the gates and I get memory. Okay, in the memory I have D flip flop, one is for P and I get another for Q, and I get another for Q. So let us set the wirings for it. So this is for P and this is for Q. Let us write it here for your reference. So this is P and this is going to be Q. Okay, so now what will be the output? P generates, P and Q generates, they generate the states which are represented by x and y. Now all of you know guys, P will become x after some time, the next stage will become present after some time. Okay, so then what we have is, and D type flip flops always, not only D type, all the flip flops always, they normally have two outputs. Okay, one, so P will generate x and x complement. Okay, and Q will generate y and y complement. Okay, so what is this? This is x, and what is this? This will be x complement. So what is this? This will be y, and what will be this? This will be y complement. Okay, now what is the Boolean equation for P? P is equal to x complement and y. So here we have x complement and here we have y. Okay, so what we need to do is we need to AND them. We need to AND them. So guys, here is the AND gate. So I change the inputs to 2. Okay, I change the face of AND gate to west and I make it narrow. Okay, so what is P? This is P, and how P will be generated? P will be generated x complement. Now this is x complement sorry, this is x complement and y. So this is y. Okay, so this is p. This is p. Okay, x complement and y. So what is q? X complement and y complement. So again, I take another AND gate. So what is q? X complement and y complement. So this is y complement. Okay, and this is x complement, and it goes here, and what is the output? Output is q, and the output is q. Okay, so guys, now we also need a clock. We also need a clock. Okay, so I get a clock here. So I give the clock to the clock input. Okay, now let us see if this circuit is working. So this is the clock. Present state is, see, 0 0 0 1 1 0, you can see, then again 0 0. So 3 states, 0 1 1 0 and 0 0, and they keep on repeating, and they keep on repeating. So guys, now what we need is, we need the present lights which should be green. Okay, so here on the side I take input output and I take this LED. Okay, so LED on color is red, so I will change it to green. Okay, so how many LEDs I need? I need 3. One for Muscat, then one for Rustak. Okay, already it is green, and one for Sohar. Okay, so guys, what was my Muscat? X complement and y complement. Okay, so which we already have. See, x complement and y complement, which is q. So simply I connect q to Muscat. Okay, so then what is my Rustak? X complement and y. Okay, so what is my Rustak? X complement and y. So do I have x complement and y? That is p. Okay, simply what I do, I take p, this is my p, I connect it to, sorry, I connect it to Rustak. Okay, now see, the present state is 0 1, Rustak is green. So what I need for Sohar is x and y complement. So y complement I have here. So guys, what was Sohar? X and y complement. So this is x, this is x, and this is y complement. So what do? We take a AND gate, we give the connections, and we connect it to Sohar. Now let us see whether the circuit is working. Sohar green, then Muscat green, then Rustak green, then Sohar green. Okay, so for your reference, let us write here what this is for Muscat, and this is Rustak, and what is this? This is Sohar. This is Sohar, and you can see our circuit working. Okay, now guys, what I need is, so light is becoming green, but in real traffic signals, so we also have yellow light and we also have red light. Okay, so now we will add those lights. So when the light is not green, so what light it is? It is red. Okay, so let us take LED. Okay, let us change the color to red. Okay, so when it is not green, what it should be red. So I take the green and are not to it, and are not to it, okay, and connect red in front of it. So when it is not green, okay, now let us run it. So when it is not green, it should be red. Okay, now when Rustak is not green, now the Rustak is green. When Rustak is not green, so what it should be? It should also be red. When Rustak is not green, it should be red. So again, now two are red, one is green. Same way I do it for Sohar. So when Sohar is not green, it should be red. Okay, now let us see. So when Muscat is green, Rustak and Sohar are red. When Rustak is green, Muscat and Sohar are red. When Sohar is green, other two are red. Okay, but guys, in our traffic light controller, we also have yellow. So when the yellow light is on, the yellow light is on between the red and green. So I take, so means between the red and green, what comes? Between red and green, clock pulses come. Okay, so what I do is I take a yellow light, which I change the color, and I connect it to what? I connect it with my clock pulses. So this, sorry, this yellow, and this is also yellow. Okay, so we connect the yellows. So here my clock is coming. We connect the yellows to the clocks. So now let us see. Now Muscat red, Rustak red, Sohar green. So yellow comes in between and the light changes. Now the light changes. Now the light changes. Okay, so guys, I hope you understand. I hope so. Sorry, this video went little long. Okay, but I tried to explain as much possible as I could. So guys, if you like my videos, please subscribe to my channel. I'll be uploading more IT lecture videos and all kind of stuff. And all of you, thanks for watching and stay tuned.